Calculate the percentage by mass of water of crystallization in the magnesium tetraoxosulfate 6 heptahydrate. Solution. First of all, we have to get the molecular mass of magnesium tetraoxosulfate 6 heptahydrate. Then, getting the magnesium atom as 24, the molar mass of sulfur is 32, the molar mass of oxygen is 4 times 4 atoms of oxygen, plus the molar mass of hydrogen is 2, plus 16 molar mass of oxygen. Since water have 7 atoms, we times it by 7 to get the sum of 24 plus 32 plus 64 plus 126, which will finally give us the answer as 246 grams. Therefore, there are 7 molecules of water of crystallization in the compound. Mass of water of crystallization is equal to 126 grams, that is 7 times 18. Therefore, percentage of water of crystallization of magnesium tetraoxosulfate 6 heptahydrate will now be equal to mass of water of crystallization divided by mass of magnesium of tetraoxosulfate 6 heptahydrate times 100 over 1, which will finally give us 126 divided by 245 times 100 over 1, which will finally give us 51.2%. Example 8. Sodium tetraoxocarbonate 4 crystal contains 62.94% by mass of water of crystallization. Find the value of X. Solution. The mass of sodium tetraoxocarbonate 4 and the water crystal can be calculated by relative atomic number in the following way. Now, looking at the formula, we have sodium tetraoxocarbonate 4 and the water of crystallization, which is having X value. Then, calculating the relative atomic mass of the elements that make up this compound, we have that sodium atom contain 23 times 2 molecular mass, plus carbon, that is 12, then 16 molecular mass of oxygen times 3 atoms of oxygen. Then the water of crystallization is having hydrogen and oxygen. We now add 2 molecules of hydrogen plus 16 molecules of oxygen to times by X. Then the molar mass of the sodium tetraoxosulfate 4 will give us 106 grams, while water will give us 18 S gram. Therefore, the mass of water of crystallization is 18 S gram, and the mass of anhydrous sodium tetraoxocarbonate is 106 grams. Since the crystal contains 62.94% of water, the remaining 100 minus 62.94 grams will now give us 37.06% and must be an anhydrous sodium carbonate. Therefore, the mass of water of crystallization divided by mass of anhydrous sodium trioxocarbonate times 18 gram of the crystal S over 106 gram of the sodium trioxocarbonate is equals to 62.34 of the water over 37.06 of the sodium trioxocarbonate. Therefore, S is equals to, by cross multiplying, we will now get 106 times 62.94 all over 37.06 times 18, which will give us 6,671.64 over 667.08. Then now the water of crystallization will now become 10 atoms. Formula mass from relative atomic mass. Formula mass from relative atomic mass is the relative mass of one atom in a given element. Relative atomic mass is equal to atomic mass of element over half atomic mass of C12, which is equal to 12 times atomic mass of element over atomic mass of C12. Writing chemical formula from valencies. Having a valency of positive S combining with Y having a negative valency of M, then the positive valency of S will move to Y, while the negative valency Y will move to A. Then we have AMYS. Looking at calcium having two positive valency combining with tetraoxocarbonate having two negative valency, we cannot see that the two valency of tetraoxocarbonate will now move to the calcium, while the two positive valency of calcium will now move to tetraoxocarbonate, which will then eventually cancel out to give us CaCO, since the two valencies are equal. Now, considering also the hydrogen having one positive valency and potassium trioxide having three negative valency, this will combine to give us H3PO3. And now let us consider the hydrogen having one positive valency combining with sulfur tetraoxide having two negative valency. The positive valency of hydrogen will move to the tetraoxosulfate, while the two negative valency will come to hydrogen to give us H2SO4 as the chemical formula. Chemical formula. The chemical formula of compound formed when the element A has a positive valency plus X combines with another element Y having a negative valency minus M, it will give us AXYM, as I have already illustrated. Empirical formula. This is the simplest formula which shows the ratio of the atom of the different elements in the compound. Structural formula. The structural formula gives more information than the molecular formula by expressing the way in which the atoms are joined together in the compound. Thus, two or more compounds can have the same molecular formula but different structural formula because the way the atoms are joined in the compound is different. Such compounds are known as isomers. Looking at this